Welcome back. In this video, we're going to be discussing the marginal rate of substitution in relation to mu, that is in relation to the marginal utility. Now, we already know that the marginal rate of substitution is the slope of the indifference curve, which is calculated by calculating the slope, the formula of the slope, which is a change in y over change in x. Now, the formula of change in y over change in x is a general formula that is applied to calculating the slope of any line. But the slope of an indifference curve is actually referring to the marginal rate of substitution, right? Now, the marginal rate of substitution, guys, can also be written as the marginal utility of x divided by the marginal utility of y, that is the mux over muy. Now, before I move on to explaining that, one thing I would like to clear is that in this video, I'm not going to be explaining why the marginal rate of substitution or what the marginal rate of substitution is and why does it decline as we move down the indifference curve. For that, probably I'm going to be making another separate video. This video is only focused on why MRS is equal to mux over muy. So guys, let's say that you have a combination on an indifference curve, let's say combination A, where you're consuming y1 number of units for good y and x1 number of units for good x and good y being respectively on the x and the y axis, right? So guys, let's draw an imaginary indifference curve here, and we all know that, as we move down the indifference curve, the total satisfaction or utility remains the same. So let's say if I move from A to C, so I need to reduce the number of units for y and then increase the number of units for x such that, and as I do so, my total utility or total satisfaction that is at point C will exactly be equal to total satisfaction received at point A. And I'm going to be erasing it to the indifference curve because I really don't need that indifference curve right now. So let's say what happens is that I'm moving down my indifference curve, and as I'm doing so, I am reducing my good y and basically increasing my good x, right? And ultimately resulting into a combination from point A to point C. Now this point B is representing a position where my number of units for good y is going down, right? So let's say that if my number of units for good y goes down and I want to calculate that as I reduce my number of units for good y, then definitely I'm going to be increasing my number of units for good x, right? But if I want to calculate that how much utility or satisfaction am I going to lose by reducing my quantity of good y or foregoing my quantity of good y in order to increase the quantity of good x. So guys, in order to calculate, we could say that let's say if I know that what is the marginal utility I'm going to get by consuming a single unit of y, and the marginal utility or the utility that I'm going to get by consuming a single unit of y is known as the marginal utility of y, right? Which is the utility on a single unit of y. And if I multiply by that by the number of units that I am foregoing by not consuming y anymore, or foregoing the number of units of y, which is represented by the change in y. So the change in y is representing the number of units that I am foregoing for y. Now if I multiply muy by the change in y, I'm actually going to get the loss of satisfaction or the loss of total utility. Basically, how much total utility am I losing by not consuming these number of units of good y. Okay, that is exactly what I've written over here as well. So for example, let's say that if the consumption of good y is decreasing to, let's say, point B, because at point B the consumption is going down, and I want to find out that by how much the utility of good y has gone down. So for that I can calculate, or I can use the formula simply the marginal utility of y multiplied by the change in y, right? Because that is going to tell me how much total utility I have declined or decreased, how much total satisfaction or total utility has been decreased or declined or reduced from the decline in the consumption of good y. So let's say that I was getting a utility of 2 by consuming 1 unit of y. So muy was 2, right? So I was getting a utility of 2, and if I multiply that by, let's say I reduce my consumption, hypothetically speaking, I reduce my consumption of y by 10 units. So my total utility has declined by 20, right? Which means that now my utility has to go up by 20 by increasing the consumption of x, right? So what we're saying over here is that the decline in total utility by consuming less of y has to be met by an increase in total utility by consuming more of x. But we know that muy dot change in y, or multiply by the change in y, is going to tell us how much my total satisfaction or total utility has declined by consuming less of y. So this is one thing that you guys need to remember, okay? Moving back, since we know that we are drawing an indifference curve, right, and we decrease the utility, we now need to sort of increase the utility of x. I mean, we need to consume more of x so that we can increase our utility so that we can be indifferent. Now, if you want to be so by the way, if you want to be indifferent, let's say, if the consumer knows that it has reduced the consumption of y, it has foregone y, and because of that the utility has gone down or satisfaction has gone down, so it has two options. Either it could end up consuming back those units that it had foregone. So you move from point B to point A back, and in that case, your utility that you had foregone, you will get that utility back up, and you will be on the same level of satisfaction as you were before foregoing good Y. Or what you can do is that, if you are foregoing the utility from consuming less of Y, you could end up consuming more of X, such that you are indifferent, right? Such that the loss of utility or satisfaction by consuming less of Y is offset by the gain in satisfaction from consuming more of X, right? If you look at the second option, that is to increase X to an extent, you increase it to the extent that the loss of utility from good Y can be compensated by the gain in utility from good X, right? So let's say what we're saying is that if you're reducing good Y, you're foregoing good Y, or you're foregoing good Y so that you could substitute it for X. So you're substituting X for Y basically. So what's going on here is that you're substituting X for Y. Okay, you're substituting X for Y means you're getting more X, and then reducing your consumption of Y, you're foregoing Y. Okay, so what's happening here is that this area is representing this is your loss of utility, and this is basically your gain in utility, right? This is your gain in utility. So we could say basically what we could say is that AB is loss of utility while BC is gain in utility. So if AB is loss of utility, right, if this is loss of utility, then BC is gain in utility. Now BC is telling us that this is the gain in utility or satisfaction by consuming more of X. And if you want to calculate how much utility you have gained by consuming more of X, you could use the same thing. You could do exactly the same thing that you did for calculating how much utility was going down. So if we know that how much utility, let's say that, if you want to find out that how much utility were you getting by consuming a single unit of X, so that could be the marginal utility of X. And if you multiply by the change in the number of units of X, that is by what extent you have increased the consumption of X, you could get the total utility or total satisfaction, or the extent of the total satisfaction that has increased, right? And this must exactly be equal. This formula must exactly be equal, or MUX multiplied by the change in X must exactly be equal to, MUY must be exactly be equal to MUY times the change in Y, such that the consumer is indifferent, right? So because the consumer has to be indifferent on A and C, which means that if satisfaction at A is equal to the satisfaction at C, then the change in total utility is zero. So if the satisfaction at A is exactly equal to the satisfaction at C, then if the consumer moves from A to C, and if I say that what is the change in total utility, then your answer must be it's zero. And why is it zero? Because the consumer is indifferent. Whatever satisfaction he was receiving at A, he's receiving the same satisfaction at C. So there's no change in total utility, right? And if I say that there's no change in total utility, exactly no change in total utility, then what I could say is that the change in utility, which is the change in total utility, is zero, right? Because both of them are giving the same level of satisfaction. Combination A and combination C are giving the same level of satisfaction. Now, I could rearrange, or I could write this formula as by saying that the MUY times change in Y is telling us the loss in utility, the loss in total utility from consuming less of Y, and if I add that by the gain in utility by consuming more of X, then since both of them will offset each other, so if I add them up, then the gain in utility should be zero. They both must be equal to zero, right? And if they both are sort of equal to zero, and I want you guys to pay attention over here, that if they both are equal to zero, and if this is the formula, right, if this is the exact formula saying that MUY times change in Y plus MUX times change in X equals to zero, then I could sort of rearrange this formula by also writing it in this way, that I could, bring this entire thing on the other side of the equation. And if I bring this entire thing on the other side of the equation, then this should be MUY times change in Y is equals to, bringing it on the other side of the equation would mean that this would now be equal to minus MUX dot change in X, right? And so if this is my equation right now, okay, then I could further rearrange this equation by saying that if I bring the change in X on the other side, right, and if I divide the change in Y by change in X, right, now look at this very carefully. Because the dots are representing the multiplication, right? If I divide the change in Y by the change in X, So if I bring this on the other side of the equation and divide the change in y by the change in x, then obviously I need to bring this over here and then divide mux by muy then, so that the equation is satisfied. So this entire equation could be rearranged like this by writing, by writing that the change in y divided by the change in x, because you're bringing it over here, is equal to minus mux over mu y, right? Perfect. Now, if change in y over change in x is a slope, which is obviously equal to the marginal rate of substitution, so if this is equal to the marginal rate of substitution, and if this is equal to this, then definitely this must also be equal to this, because this is equal to this, right? So if change in y is equal to the MRS and if change in y over change in x is equal to the MRS, marginal rate of substitution, and change in y over change in x being the slope is also equal to the marginal utility of x divided by the marginal utility of y, then MRS must also be equal to the marginal utility of x over marginal utility of y. And that is exactly proved by this equation as well. Change in y if change in y over change in x equals to the MRS, and if this equals this, then this must also equal to this. And that is why if you read in the economics literature, it's written that the marginal rate of substitution is equal to mux over muy. So this video is explaining the mathematical derivation of why the marginal rate of substitution is equal to mux over muy. And I've also mentioned the steps over here. You can actually pause the video and copy this down, because this is exactly what I had just said right now. So I hope you enjoyed the video. I'll see you all around in my next video. Until then, take care.